So one thing that you might want to think about when it comes to fractions, and I know probably everybody in this room are like, oh my God, fractions, I just finished doing all this. The depth of our understanding of fractions will help us when we build off this later, especially when we get into ratios and proportions. I want you to think of a whole number rather than this. This is a whole number, right? Okay, easy. Let's go back to kindergarten. This is a whole number. But if you think of all of your whole numbers written like this, okay, every whole number is written over a 1, every single one. That's how we think of whole numbers, or how we should be thinking of whole numbers. We only see it as 1, right? And the reason for this is if we have this same rectangle that Patrick was talking about, this is currently one rectangle, right? So how much of this rectangle do I own? I own one of 1 rectangles. And that's why we can think of whole numbers like this. And this will help us to understand how to build on the fractions, right? Because if I take this rectangle and I cut it right in half, right? So now what happens is, since all whole numbers are written over a 1, right? The one that's on the bottom is the unit, right? How many pieces we had. So originally I had 1 of 1 available piece. But if I take this one now, I have 1 of 2 available pieces, right? Or I have a half of it. So we want to think of this line right here as an of, which is also a dividing line. Okay? So try, if you can start with whole numbers are written over a 1, no matter what the whole number is, a 2 written over a 1, right? So I can have, that tells me that I have 2 whole pieces, because one of these is this, and I have 2 of them. So I've got 2 of the whole pieces, right? And that's all this means, okay? So if we can build on our understanding of fractions, thinking this way, that every single whole number is written over top of a 1, then fractions will make sense even faster, because the number on the bottom is the total number of pieces available. And as soon as I change the number of pieces, I put a line there. Now I have 2. That becomes the number on the bottom. If I divide it into 20 pieces, that becomes the number on the bottom. That's the number of available pieces. The number on the top is how many of them I'm talking about, or how many I'm concerned about. Okay, so have a look here at the board. Here's another way to think about fractions, especially improper fractions. Remember what Patrick said? He said the denominator is the number of pieces available, right? And so that's our denominator. Our numerator is the number of pieces that we're concerned about. So this is the total number that make up a whole, right? And the numerator would be the number of pieces that we're considering, whatever it is that we're doing. So how many quarters, right? So if we go through, if we know that we are concerned with the fraction with a denominator of quarters, and we look at the number of quarters up here, these are all equal pieces. Okay, we know that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we could, based on the instruction that we got from Patrick, we could say 11 quarters, right? Because we're talking about quarters, and 11 is how many we're considering, how many of those quarters that are of some sort of significance, okay? But every time your numerator equals your denominator, you can just convert it to a 1, right? So 4 quarters, right? So 1 quarter, right? And another quarter, and another quarter, and another quarter. If you add those together, you get 4 quarters. Remember what I said about whole numbers? If you write a whole number over a 1, that's how you should view a whole number. Well, a 4 written over a 4 is equal to a whole number. 4 over 4. Think about it like reducing. right? Can I make this fraction smaller? I can, because there 1 goes into 4 4 times, and 1 goes into 4 4 times. So 4 over 4 just equals 1 over 1. And like we said before, a whole number written over a 1 is just a whole number. So really, this is just equal to 1, right? So notice that as I add the numerators across here, as soon as they equal the denominator, I can convert this into 1. So I can convert this into 1, right? As soon as I got 4 quarters, that's another 1. So really what I have is I have one group of 4 plus another group of 4, plus I have 3 of 4 left over. So when we're adding fractions, we can do it simply thinking in this way, right? I can say 11 quarters or 2 and 3 quarters. They are equal to the exact same thing. And if you ever wonder, well, how do I know for sure? Like, how can I prove that this is right? Well, look at how many times you grouped 4 together. Once and twice, right? So twice you grouped 4 together. 2 times. So 2 times 4. Okay? So 2 times 4 is 8, and you have a 3 left over, right? Right? So plus the 3 written over the 4. Now this is, it's hard to see that, sorry. 2 times 4 is 8, right? Plus 3, and you write it all over 4. And here's the reason. If we're talking about the denominator, this always rules, okay? Quarters, we're talking about quarters, it stays quarters. So everything that we do is written over 4, everything. So if I'm trying to work this backwards and figure out how do I know for sure that 2 and 3 quarters equals 11 quarters, I do 4 times 2 plus 3 equals 11, and we're still talking about quarters, okay? So it's just a couple of ways to think about it, okay? Every time we get a group that the numerator equals the denominator, just convert it into a 1, right? And that makes it easy to figure out if you want a mixed number, right? So the mixed number is the 2 and 3 quarters. It's mixed because you're mixing a whole number and a fraction. So that's a mixed number. This is an improper fraction. It's improper because the numerator is bigger than the denominator. It's not supposed to be in typical fractions, right? Common fraction is this here, 3 over 4, right? When the numerator is smaller than the denominator, that's a common fraction. An improper fraction is when they're inverted, right? When the numerator is greater. And then a mixed number is when you mix a whole number and a fraction together. There's a general rule that all inch measurements or all decimal inch values need to be acknowledged to 3 decimal places. Now, I will tell you, carpenters, that this rule isn't as important across the board, okay? And the reason is when you're doing rough cutting, right? Obviously with tape measures, mostly tape measures, I guess, if you cut plus or minus 1/8 of an inch, it really doesn't change too much on the grand scale, right? Everything gets pulled together. I'm not saying it's not important, but cutting on a chop saw to 3 decimal places of an inch is not realistic, right? But what the print calls out when there's a need for information about, well, the number of decimal places talks about the accuracy. So the more decimals, the more accurate. So if you don't have any information telling you how many decimals, if it's an inch your print, you want to cut to 3 decimals or manufacture to 3 decimals. That's the industry standard. But what you do need to understand is when decimals are called out, no matter what your trade, when decimals are called out, there's a reason why they're called out to 3 decimals or 1 decimal, or in some cases, they're just called out as a fraction. Here's something machinists would typically see on a print. At the very bottom of a print, you'll see what's called a title bar, okay? And in that title bar, somewhere in there, okay, you'll see all kinds of information about the part, what it's called, where it's from. You might have a date, right? A signature of whoever signed off on the part, okay? The name of the part, right? You'll see this on all prints, right? Maybe the company that sent you the print. But somewhere on here, it's going to tell you what the tolerance is, that are general tolerances that apply. And so if I took, let's say that this box here is the tolerance box. I'll just blow it up a bit. So you might see something like this, decimal, okay, 1 decimal place. So you'll see that by a decimal with an X equals plus or minus 0.01, okay? So that's saying that anytime you see a single decimal place on this print, that you can manufacture or cut that part plus or minus 10 thousandths of an inch. For machinists, okay, you're going to see this. For carpenters, those values will be larger, right? Obviously. But the general rules apply for everybody. 2 decimal places may say general rule is plus or minus 0.005. Okay, so notice the more decimal places, the more accurate or the tighter the tolerances have to be. Okay, and then you might see 3 X's or 3 decimal places are plus minus 0.001 thousandths of an inch. So machinists will see this, welders will see this, carpenters will see something similar, but these numbers in this column will be greater, right? But the principle is the same, right? The more decimal places, the tighter that tolerance has to be, or the more accurate that measurement has to be. Anytime you see a fraction called out on a print, the general rule is that fractions, their tolerance will be equal to 0.031. I think it's 31 thou. Okay, so you have an even larger tolerance. So if it's fractional, it's saying, well, you got to make it a ½ inch, but you got a 31 thou spread there, plus or minus, right? So you can be within a 62 thou deviation from nominal and still meet the required print dimensions. So why are we talking about this? When it comes to decimal fractions, no matter what our trade is, we have to know what the expectations are when we're manufacturing. Like if we forget the odd thing in school, it's not the end of the world, right? But we need to know what the general rules are. So everybody knows that for our class, okay, so this is how we're going to do it here. How it applies in your specific trade is up to you and your instructor, okay? Because I'm not a master of all trades. I'm a machinist by trade. Okay, so in this class, if you have to write an answer in a decimal fraction, and it doesn't tell you how many decimals to write it to, okay, all inch answers are going to be to 3 decimal places. Okay, so don't forget that. All metric, and this is an industry standard for machinists, but we're going to apply this for everyone in this class. Metric is 2 decimal places. Okay, so that's our industry standard. Okay, so let me throw something at you here. If we want to talk about precision, okay, we want to talk about accuracy, clear communication. So if I said to you, take this number, okay, so take 7/8, and I want you to convert that into a decimal fraction and round it to 4 decimals. Okay, so all you're going to do is you're going to get your wonderful scientific calculator and you're going to go, okay, 7/8, okay, yeah, that's easy. So it's 0.875. So what's the instructions say? The instructions say to round it to 4 decimal places. Well, my calculator only gives me 3. That means that any decimal place following this is a 0. Do I need to write the 0? The instructions say round all, convert all common fractions to decimal fractions and round to 4 decimal places. Do I need to? Is this any different than this? Is it any different? Okay, you don't have to feel like you have to answer, but you're always welcome to. Okay, it is different. Absolutely different. Why? Because of the precision connection, right? If I look at a print and I see, oh, manufactured at 0.875, first thing I see is 3 decimal places. So I know the degree of accuracy is less than 4 decimal places. And I showed you in that little title block, right? That is common. A title block will tell you the required tolerances for anything that's 1 decimal, 2 decimal, 3 decimal. So if I see a 3 decimal number, I know it's not as tight a tolerance as a 4 decimal. But if I'm asked, hey, convert this to a decimal fraction and round it to 4 decimals, what that tells me is, oh, they don't want this part 7/8. They want this part 0.8750. Okay. Now, as a common fraction, if you convert this to a common fraction, you get 7/8. But this is why we use decimals, because I can't reduce 7/8 anymore as a fraction, but I can reduce it as a decimal fraction. So accuracy and precision is a big part of this. So what I'm trying to say to you is follow instructions. And this is important to me as an instructor, but when you get into your trade in the field, listen to the instructions, because that's what matters, right? It's not about, hey, make sure you make all of those features exactly to 7/8 because this has to fit inside that mating part. Whoa, right? If I made all those features to 7/8 and I know that the industry standard for fractions is 0.031 inch tolerance, that's never going to fit with a mating part because I have a 62 thou deviation allowance. So it's important to communicate properly what it is we want, right? And what it is that we intend to do. So let's just do a couple of examples together of rounding to a specific number of decimals. I can't tell you how many people don't get this. Okay, so let's just do 4 or 5 examples here. Decimal 4873210. Okay, decimal 211396. Decimal 99694. And let's go 1.045. Okay, in this first example on the top, I want to round to 2 decimal places. Okay, that's it. I want to round to 2 decimals. So here's what I want you to do. Whatever way you do things now, just kind of set it aside for a second. Even if you're 100% right, don't care. Okay, I want to round to 2 decimal places. So at the end, I only want to have 2 numbers showing, right? So if I only want to round to 2 decimals, I only need 3 to work with. I don't care how long this number is. I only need 3 numbers so I can round to 2. So I'm going to take everything past the 7 and I'm going to pretend it doesn't exist. Because it doesn't. It doesn't matter. It doesn't change anything about what I'm about to do. Okay? Because when I round this to 2 decimals, this third number tells me what to do with this. All right? So if this third number is a 5 or higher, then this number, the 8, will go up by 1. If this number is a 4 or lower, then this number stays the same. So don't be confused. Get rid of the numbers you don't need. Leave 1 number beyond the number of decimals you have to round to. So my answer is going to be 0.48? No, 0.49, right? Because this is greater than 5, that means the 8 goes up a number. Okay, and then I've rounded properly, 0.49. What about this number here? I want to round to 4 decimal places. So I've got 5 numbers. I eliminate the 5th. I don't care about it. It means nothing. Or eliminate the 6, right? I want 4, so I keep 1 number past. I keep the 9 because that's the 5th number. This number, if it's 5 or bigger, it increases this one by 1. So now I have 0.2114, right? Good. I want to round this number to 4 decimal places. I have 5 numbers. This last number tells me what to do with this number. It's a 4 or lower. This number stays the same. So this number becomes 0.9969. Nothing changes. We just eliminate the 4. Okay. What about this one here? I want to round this to 1 decimal place. Okay. So if I want to round to 1 decimal place, get rid of that last number. You look at this number and it tells you what to do with this. It's a 4, so the 0 stays the same, right? So it was 1.04, it's going to be 1.0. Okay. Do I write the 0? Do I need to write the 0? Yes, because you've been asked to round to 1 decimal place. It does not matter if it's a 0, it needs to show because it talks about the degree of precision, right? Even though you may be thinking, well, that 40 thou, I mean, if this was precise in any way, isn't that where the precision is? No, because remember in the title block, it says that all 1 decimal place numbers have this tolerance. And that tolerance is plus or minus, let's say 10 thou. Well, that's 30 thou smaller than this, right? So there is still a degree of precision that applies to that first decimal place. So you need to understand how to round properly. This is a key to a lot of different math that's coming up, right? If you're going to round to 1 decimal and there's 10 numbers, get rid of 8 of them. Just eliminate them. Don't look at them. Scratch them out. You only have to look at the 2, and then the 1 tells you what to do with the other one. Keep it simple, all right? How do we convert a decimal fraction back into a common fraction? Let's take, for instance, the fraction, the decimal fraction we've just been talking about, 0.875. Okay, so maybe you don't have a calculator with you, and you can't remember, what this common fraction value is. So here's a simple way to do this. We're gonna convert this by turning it into a much larger common fraction. So I'm gonna take this number and I'm gonna rewrite it without the decimal. Okay, so just drop the decimal. Instead of the decimal, put your division line. Okay, so this number becomes the numerator, and then below it, write a 0 for every number that is on the numerator. Okay, so 3 numbers are on the numerator, write 3 zeros, and then write a 1 in front. This will apply for any decimal fraction that you need to solve. Okay, step 1, eliminate the decimal. Step 2, change the 875 into the numerator. Step 3, write a 0 in the denominator section for every number in the numerator, and then add a 1. Okay, now you have 875 divided by 1,000, right? So in fractions, we want to reduce to the lowest fraction. We want, this is still correct. This is a common fraction, but don't give me that as an answer. Put it in lowest terms. Okay, lowest terms. Well, how do I do that? Well, we need to find a number that divides equally into both of these. So there is no one way to do this, guys. You don't just say, oh, well, it must be this number, right? It's not simple. Sometimes you got to work your way down. So what I like to do is I try to see quickly, is there a large number that would divide into both of these? And right away, I see a 25, okay? I know that 25 will go into 875, and I know 25 will go into 1,000, right? Because 75, 3 25s are 75, and how many 25s will go into an even hundreds? So I can figure that all out, right? So I can, on my calculator, I can do 875 divided by 25. I think I wrote it down here. Yeah, so that equals 35. How many 25s Because how many 25s in 875? 35. How many 25s in 1,000? 40. Well, now I've reduced my fraction greatly, right? Now it's a little bit easier to manage. And now I see, oh, geez, I can divide both of these by 5, right? I know that for sure. How many 5s are in 35 here, right? How many 5s are in 40? So now what I've done is I very quickly reduced or converted this decimal fraction into a common fraction, but do not forget this, okay? You must convert all of your answers into lowest terms. What if you're out on the floor or out at a job working on a site, and you've got all your tools, you're all ready to go, and you only ever work in Imperial, and you're given a metric print. You know, what do you do now, right? How do you don't have anything to measure with, right? You don't have any metric measuring tapes. You don't have any metric measuring equipment at the shop or whatever the case. You just have Imperial. What do? You're given a metric print. So we want to be able to convert back and forth from Imperial to metric and metric to Imperial. If I have a metric number, so if you got your metric print and you want to convert into Imperial, then all you have to do is take your metric number and divide that by 25.4. So if it's 19 millimeters, and you need to know what that is in Imperial, then divide that by 25.4. Okay, so I just take my calculator, I'll go 19 divided by 25.4, and that equals 0.748 rounded to 3 decimals. Okay, so that's 0.002 thousandths away from 3/4 of an inch, right? Because 3/4 of an inch is 0.750. Okay, so if you take your metric number, divide by 25.4, this is your magic number here, it will give you the inch equivalent. Okay, and likewise, if you take your inch, right? If you take your inch number, so let's say 0.500, okay, and you multiply by 25.4, right? So take your 0.5 times 25.4, and that gives you 12.7 millimeters. This is the number, guys. So metric, you have a metric number and you need to convert it to Imperial, you divide by 25.4. You have an Imperial number and you need to convert it to metric, then you multiply, right? Because millimeters are smaller, so you have to multiply this, right? Millimeters are smaller, so you have to divide it, okay? So remember this number. Basically what this means is that 1 inch is equal to 25.4 millimeters, okay?